Okay, okay, hopefully my voice is clear to you. Please confirm me. If there is any noise, then please also let me know.
Yes, sir, it's clear.
Okay, fine. I will start with there is an example of a histogram equalization, and this example is very important. And we are used histogram equalization to enhance the details or to equalize the different gray levels uh, that exist within that particular image. And this is a procedure to perform the histogram equalization, and there are four steps involved in it. And the first one is finding the running summation. Second one is normalize the values. Third one is multiply the values and maximum gray level value, and then map the gray level values to the result. So in this, there is a question is given to you, and the question is to perform the histogram equalization of the image, and hopefully you are able to understand what it means. That is a matrix is given to you, and which is nothing but that is a 5 by 5. There is a image, a 5 by 5 image. There is a 5 by 5 image is given to you, and these are the values which value of a gray level and or representing the at a particular location. So hopefully you are able to understand this point. And your first step now, you have to find out the gray level first of all. There is not a step we have yet started, but please know that first we have to arrange the gray level and the number of pixels. And in this, yes, the maximum value of a gray level is there is a 5, and there is not more than 5. And how we can recognize which kind of image is this, or how many bits involved in to form this image? That is a 2 raised to power. If we are assuming that there is 2 raised to power 2, that is a 4, whose range is 0 to there is a 3, and definitely there is a 4 is there and the 5 is there. So we can't assume that. Next, we can assume it as a 2 raised to power 3, which is representing the 8, which exists from 0 to 7. And there is no any value which is more than 7, so we can consider that is 3-bit image. So in the 3-bit, there are 8 possible combinations. That is 0, 1, 2, 3, 4, 5, 6, 7. And the number of pixels which have a gray level 0. Please note that first we have put the values of a gray level from 0 to 7 here. Then we have to count the pixels which fall under that particular gray level. Now you can see that is there any 0? There is no any 0. So we can write it here 0. How many ones are there? There is no any 1. So we can again write it as a 0. How many twos are there? There is no any 2. So we can write it as a 0. Now the next one, 4. Yes, sorry, 3. How many threes are there? There is, 1 second. How many threes are there? There is 1, 2, 3, 4, 5, 6. Okay, the next, how many trees are there? Yeah. And in this slide, we have a six trees. How many fours are there? There is one, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, and 14. 14 fours are there, and then five fives are there, and 0, 6, and 0, 7. You can just go through it. Now we have to calculate the running sum of the histogram value. So what is the meaning of a running sum? Now you can do it very easily. First, you have to add. You can simply put it here. If 0 is there, you can simply put it here 0. Now you have to add these two values. That is 0 plus 0. That is again equal to 0. So you have to add these two values. That is 0 plus 0. You will get 0. Now you have to add these two values. That is 0 plus 6. Then you will get 0 plus 6 is 6. Now the next one is you have to add. There is 6 plus 14, which is equal to 20. Next, you have to add these two values. That is again 25. So the result is there, and you have to add this 25 with 0. Then definitely the ultimately result is 25. Then again 25 plus 0. Then you will get the 25. So this is a running row. There is a running sum row. And another step involved in it. Please note that in a running sum, you will get the 25. There are 25 values are there. And now you have to divide the running sum. You have to divide the running sum by the total number of pixels. So the total number of pixels are 25. 5 into 5, there is a 25. Again, you have to divide the running sum with there is a total number of the pixels. And once you have, okay, yeah, still you no need to divide it, but please write it in this format. And hopefully there is no any problem in this slide. Now the third step is you have to multiply these values. You have to multiply these values with the maximum gray level we have considered. And the maximum gray level is a 7. Here, there is a mention here. So the maximum gray, the maximum gray level is 7. So you have to multiply with this, and again you will get 0 here. There is again 0. There is 0, and how much value you can get? There is already written here. There is okay. The next point. Once you have multiplied all the values, and at the end you will get this result. So this is a uh, this is a result what you have got, and then you have to put it over here with respect to the gray level. You have to check it out here. There is 0, 1, 2, 3, and with the 0, 1, 0 from 0 to 7, and you have to write it in the same way. And there is 0, 0, 0. There is 2, 6, 7, 7, 7, and again, now you have to. This is your input matrix or input image which is given to you. Now you have to replace all these values with respect to the equalized values. So here you can just replace 4 is actually replaced with the 6, 3 is replaced with the 2, sorry, uh, 3 is replaced with the 2, 4 is replaced with the 6, 5, 6, 7 all are replaced with the 7. So you have redrawn that particular image. So this one is your equalized histogram. Okay, if there is any problem in this question, then you can please ask, and otherwise I will make another diagram so that you can understand uh, 1, 0, 1, 2, 3, 4, 5, 6, and 7. So there are 7 gray values are there. This is 1, 2, 3, 4, 5, 6, and 7. So in this case, there is a no one is there. Again, there is a 0. Again, 2 is also 0. That is a 0. Again, 0, 1, 2. That is 1, 2, 3, 4. There is 5, 6, and 7. Again, these are the number of pixels. That is 1, 2, 3, 4, 5, 6, and 7. So in this case, there is a how many pixels with the zero value? There is no any pixel, so you can write it as a zero. For one, you can write it as a zero. For two, you can also write it as a zero. How many threes are there? We have a six. So we can just draw it as like that. And how many? We have a 14. Yes, we have a 14 fours. So it is like that. That is beyond this one. There. And how many fives are there? We have five fives. Uh, and how many six are there? There is no any six. So that is a definitely this is a histogram of that particular original image. And what you can say that it is a uh, that is a light histogram, dark histogram, or a low contrast histogram. Definitely, if you will compare with the what I have shown you in a previous presentation, there is a low contrast image. And once you have equalized that image, and you will get the there is a 1, 2, 3, 4, 5, 6, and 7. You can also write it here. There is 6 and 7, and this one is a 0. There is 1, 2, 3, 4, 5, 6, 7, and it will go beyond the 1, 2, 3, 5, 6, and 7. Now you have to calculate how many okay, how many pixels are there having the zero gray level? There is no one. So you can write it here. That is a zero. Again, though there is no any one. So how many twos are there? We have a six twos. How many threes? There is no any three. Four, no four. Five, no five again. There is a how many six? There is around 14, not 14. Oh, okay, let me check. One, two, three. Oh, okay, that is a 14, around 14. 14, there is 6 are there. And how many sevens are there? There is a 5. So please note that in this, the pixel values have been distributed throughout the gray level. So please note that that is a very small image. So we are not able to get the these values in between the 2 and 6. But definitely when you are working on a large size image, you will get the values at this particular point. And our purpose of understanding the histogram equalization is to understand the is to instead of looking at that is on a darker side, on a center, or in on a to distribute the uh, intensity level. Distribute the pixels throughout the intensity level instead of particular or a specific range. So this is a method of a histogram equalization, and you can just go through this example once again. Please do it. Go through this example very carefully. And if you have any question regarding this, and we can handle by now, or we can also handle this question on tomorrow. Please let me know if you have any question for now. You can ask me, or you can also ask me regarding this on tomorrow. So hopefully you all are uh, uh, able to understand the histogram, what is a histogram, and how we can equalize the histogram. Okay, fine, Ati. If it is clear, then it is okay. If there is any question, then you can please ask me on tomorrow. Oh, and I will upload the lecture as well as PPT on your Google account by today end.